Alright, today's lesson we're going to continue with polynomial functions, and we know from quadratics that if we have a quadratic function that does something like that, we know whether it's up or down, we know what the y-intercept is, but remember it's the x-intercepts that are important to give us the zeros of the function. So if you had, let's suppose our polynomial graph was x minus 3 and x plus 2, whatever that would work out to, we know that our zeros are then going to be 3 and negative 2, which show up as our x-intercepts. So because of that, quite often we want the equation to be factored or factorable. If we can get the factors, we can then get the x-intercepts, which helps us quite a bit in terms of determining what the graph is all about. So the trick then is, how do we factor a cubic or fourth degree or fifth degree polynomial where we can't just simply factor like we did with a quadratic? And the answer to that is we have to do long division. We have to simplify these things by doing long division to try to get a smaller factor. So we're not going to do so much in terms of getting the factors today. What we're going to do is basically just review doing long division. So the first thing is exactly what I said, is if we can get something factored, that'll give us the x-intercepts. And from the x-intercepts, we then could know the graph. So if we look at this example, we have x squared plus 3x minus 18. We can factor that into x plus 3 and x plus 6 and x minus 3. We then know the zeros would be at negative 6 and positive 3. And from the graph, we know it's a quadratic. We know it's positive, and we know our y-intercept is negative 18. So from that, we would know our graph would look something like that. So having the x-intercepts will help us determine the polynomial graph a lot better than just what we know so far. So the trick then is, how do we get those? Well, if we graph them, graph the equation, you can always find those x-intercepts from the graph. And that'll also work for a third, fourth, or fifth degree. If you graph it and find your zeros, go second calc 0 and determine them that way, that will work. But we need to also know how to do them algebraically, and that's our focus today, is getting those things algebraically. So to get an x-intercept algebraically, we basically, the idea is how do we do that? So we need to factor, but how do we factor a third, fourth, or fifth degree? We're going to have to do some long division. So let's quickly go through a long division question, but before we get to the actual question, let's try in terms of numbers. So let's just do a simple one here. If I gave you 312, actually let's just do 31, it doesn't need to be that big, and let's divide that into a number like 7, 4, 5, 3, 2. So it's important when you're doing these to kind of think of all the steps we do in long division when we were in elementary. So what you do is you'd ask yourself, how many times does 3 go into 7? And we'd say, well, that's 2 times. Then we'd multiply 2 times 3 to get 6, and 2 times 1 to get 2. So 31 times 2 would be 62. Then remember, what we do is we basically subtract that from what's above. So 74 minus 62 would give us 12. We bring down a 5. And now we're doing the same thing. We're saying, how many times does 3 go into 12 now? So 3 into 12 would be 4. Multiply again, so 4 times 3, 4 times 1 would give us 124. Then remember, we want to subtract all of that. So the trick with subtracting is really what we're doing is we're adding the opposites. So we have 1 minus 1 is 0, 2 minus 2 is 0, 5 minus 4 is 1. Bring down a 3. How many times does 31 go into 13? 0. So we could multiply that and subtract, which isn't going to do anything, so let's just bring down another 2. So now how many times does 30 go into 130? Well, that would be 4. We already know 4 is 124, so we go 4, 124, we'd subtract the 124, and that would give us an answer or a remainder of 8. So in this case, we'd say 74, 532 divided by 31, our answer is 2404. Remainder 8. Or another way of writing it, we say 2404, and we'd have 8 out of 31 left over. So on your calculator, if you actually divide this, it should give you that exact same decimal. Whatever 8 over 31 is, Let's try that quickly. So 8 divided by 31 is 0.258. So we would get 2404.258. So if you try that on your calculator, take the original, 74,532, divided by 31, we do indeed get that exact answer. So the point of this is we're not going to be doing long division with numbers like you did in grade 5 or whatever it was. What we're going to be doing is long division with algebra. And it seems like it's complicated at first, but what you want to do is think of it in the exact same terms we just did. So in this case, we want to divide 9x plus 4x cubed minus 12 by x minus 2. So let's write it out the same way we just did for regular long division. So we'd have x minus 2. We're going to divide all of that into this cubic function. With long division, you want to write them from highest to lowest term. So let's write the 4x cubed first. Then we have a 9x, then we have minus 12, but there is no x squared term, so it's a good idea in a lot of cases to put those in. So let's put in 0x squared, then the 9x, then the minus 12. Okay, so now what we're ready to do is start doing the long division process. So how many times does x go into 4x cubed? Well, x times what would give you 4x cubed? That would be 4x squared. So it's always you want to multiply those to get that first answer. So now when we multiply, FOIL it out, 4x squared times x would give you 4x cubed. 4x squared times negative 2 would be negative 8x squared. Okay, remember what we want to do now is we want to subtract those. So it's a good idea to change your signs. So let's think of it as adding the opposites. So we'd have 4 minus 4 is 0. 0 plus 8 would be 8x squared. Bring down our 9x, and now we start all over again. So how many times now does x go into 8x squared? It would be positive 8x times. So 8x times x, so 8x squared. 8x times negative 2, negative 16x. Once again, we want to subtract all of that. So let's add the opposites to make it easier. 8x minus 8x squared cancels. We should always get those ones canceling. You never want to have anything left over. And then 9 plus 16 would give you 25x. Once again, bring down the negative 12. And we got to do this one more time. How many times does x go into 25x? 25 times. FOIL that out. 25 times x. 25 times negative 2. And remember, we want to subtract that. So now when we do that, we get, let's add the opposites again. So these ones cancel to be 0. Minus 12 plus 50 is 30, oops, not 32, 38. So in this case, we would say our remainder is 38. So what does all this mean? Well, when we divided these two out, our final answer is 4x squared plus 8x plus 25 with a remainder 38. So what we do is we write that as 38 divided by what we're starting with, just like we did with a regular number. So 38 over x minus 2 would be the actual remainder of the function. And that's it. So when you're doing long division, you just got to follow those steps. It takes you a bit of time, and it's not easy, but you just want to think of it always as just like you would with regular numbers. Okay, so let's try another one. So here we got 2x cubed on the top, and we're dividing by x plus 3. So let's write it as a long division setup. This one is in order, x cubed, then we got x squared, then we got 27x minus 36, so that's good. So now we're ready to go. How many times does x go into 2x cubed? 2x squared. Multiply those out. 2x squared times x, 2x cubed, 2x squared times 3, 6x squared. We want to subtract all that. Okay, so once again, these would be negatives. We change our signs. Those ones cancel. We end up with negative 5x squared. Bring down our 27x. And we're ready to start all over again for the next round. X into negative 5x squared goes 5x times. Multiply that out. Negative 5x times x. Negative 5x times 3. Subtract by adding our opposites again. So that gives us 0 for the first one and negative 12x for the last one, bring down our 36, and we're ready to go. How many times does x go into negative 12x? That'd be minus 12 times, so minus 12 times x, minus 12 times 3, subtract those by doing our opposites, and in this case we see that we get 0 for that and 0 for that. Those ones cancel out. So in this case our division, once we divide it, is just our answer with no remainder, so minus 5x minus 12. And that's it for that one. So doing the long division, like I said, a little bit of work, a little bit of time, be careful with your signs, but once you understand the process, it's the same thing over and over again. Okay, so we're going to do one more, and then I'm going to show you how to do synthetic. Or actually, let's do synthetic for this one. Actually, let's backtrack to the last one, and I'll show you synthetic, and then we're going to do that from here on out. So a synthetic division, it's just basically, it's getting the same answer, but it's doing a little bit quicker and a little bit of a shortcut. So what we do is we basically set it up as we only worry about the coefficients, because that's really all we're dealing with each time. We know it's going x cubed, x squared, x, and all the way down. So how we do this is we basically write the question again, but we just write our front coefficients. So for this one we got a 2 for the 2x cubed, we got a 1 for the x squared, we got minus 27, and we got minus 36. And usually what we do is we write this as a kind of an upside down type of division, and the number we put out front is what our factor, not our factor, but what our 0 would be. So if we're dividing by x plus 3, that means we're actually going to take out a negative 3, right? If that was our 0, we'd say x equals negative 3. So we do the opposite there. That's about the only thing that's different. Do the opposite out front, and then the rest of the numbers stay the same. And then all we do is basically carry down numbers and multiply. So we bring down the 2, and then now we multiply. So negative 3 times 2 gives you negative 6. Add those two together. So you carry it down, multiply, add. So 1 plus negative 6 gives you negative 5. Now we multiply again. Negative 3 times negative 5 gives us positive 15. Add those two numbers together. So negative 27 plus 15 gives you negative 12. Negative 3 times negative 12 is positive 36. Add those together, we get 0. So now when you get this as your final answer, we just basically have to put the x's back in. Our last number is our remainder. The next number is our constant. The next one is our x. The one after that is x squared, and we'd continue if there was more numbers. So our final answer then is 2x squared minus 5x minus 12 with a 0 remainder, which is exactly the same answer we got by doing the long division. So a lot of people like synthetic because it's a little bit shorter, a little bit faster. You're not worrying about all the x's and so on. So let's do a couple of those. So here's another one. So we're dividing by x plus 2, so we'd write minus 2. And we're going to divide that into 2x cubed, 5x squared, minus 1x, and minus 6. So the process again, carry down a 2, multiply. Negative 2 times 2 would be negative 4. Add those. Negative 5 plus negative 4 is 1. Positive 1. Let me erase that. Multiply again. Negative 2 times 1 would be negative 2. Add those. What gives us negative 3. Negative 2 times negative 3 is positive 6. Add those. We get 0. So we have a 0 remainder. Remember, this is our constant. This one would be our x. This one would be our x squared. So our final answer is 2x squared plus x minus 3. If you ever wanted to check if you did it right, you could FOIL these out. If we just take that 2x squared answer, times it by what we're originally dividing, FOIL it all out, you will get the top. You will get what you started with. Okay, let's try one more synthetic. So here we've got plus 4 on the bottom, so we want to do the 0 would be negative 4. And then on the top we put in all our coefficients, so we got 1x cubed. We have 0x squared, so let's put that 0 in to hold that spot. Then we got negative 1x and negative 10. So same process, bring down the 1, multiply. So negative 4 times 1 is negative 4. Add the 2, multiply again. Negative 4 times negative 4 is 16. Add the 2, Multiply again, we get negative 60. Add the 2, we have negative 70. So in this case, our negative 70 is our remainder. So we'd have plus 15, 4x, and 1x squared. So our final answer should be x squared minus 4x plus 15 minus 70 over x plus 4 was what we divided with originally. Okay, so if you do have a remainder, write it as that over the x plus 4. If you don't have a remainder, then obviously you don't need to write anything. Okay, so that brings us to the remainder theorem, and this is what's going to lead us into actually completing these things by factoring. So when we divide a polynomial by a binomial, the remainder is going to help us determine whether it's actually a factor or not. If we get 0 for a remainder, then that means that was an actual factor. If the remainder is not 0, then we didn't get a factor. So if we go back and look at these previous examples, this x plus 4 gave us a remainder of negative 70, so it's not a factor. But if we look at the previous one, we did get a remainder of 0, so that means this x plus 2 is indeed an actual factor. So what we're going to be doing with this stuff then is taking that final answer, right? So we already know, oops, I really didn't need to erase that. What we already know is that x plus 2 was a factor of the original. So when we divided it, we were left with 2x cubed, or 2x squared plus x minus 3. So now all we would have to do then is factor whatever's left over. So if we actually factored that, we would get, let's just see if I can get this to work out quickly in my head. 3 and 1. And we would want positive 3 and negative 2. That should work. So in this case, if we factor this leftover answer now, we'd have x plus 2 as our original factor. Then we'd also end up with 2x plus 3. And we'd also end up with x minus 1. So that original numerator, the whole polynomial, that was a cubic polynomial, we could break it into these three factors. Now that we know the factors, we know that our zeros are going to be negative 2. This one will be negative 3/2, and our last one would be positive 1. So from that, we could actually figure out our graph pretty easily. So we know our zeros are at negative 2, negative 1.5, and at 1. Our original graph was positive 2x cubed, so we know it's going upwards. We've got a y-intercept of negative 6, and that's it. So we have 3 zeros. We know that we have 3 zeros. We know the graph's going to do something like that. It's going to go through our x-intercepts, through our negative 6 y-intercept, and because it's positive cubic, we know it's going to be some kind of shape like that. So the whole point of all this is, can we get those x-intercepts? The trick is, how do we get them when it's a cubic or quadratic, and that's where we have to do this long division. So tomorrow we're going to work on more of this, of actually getting those x-intercepts. We'll go beyond just the long division and do some extra factoring as well. And that's all.